Hello, everybody. My name is Wakene. I am a student attending Vanderbilt University, and I am a participant for the summer 2024 RU program at UT Dallas. Here is my topic, is my project. The title of my project is Exploring Exposure in Generative Adversarial Networks, Working Towards the Security of Individuals from AI Synthesized Voices. So to begin, I have a little bit of background for you guys, starting off with AI voice generation. So to begin, recently there has been a significant advancement that has led to the improvement of AI that we see today, and that has been through neural networks. And this has shown to be, a spark plug for the field of deep learning, and this has also allowed computational models to learn, representations of data. And why this has been such a huge step for AI is that has led to significant improvement in areas such as voice and object recognition, along with voice generation that we have seen today. So we've probably seen, AI voice generation every, somehow, some way over the last few months, especially, online on our phones or in the internet. But how effective is it really? And we can see this here through research that has been made trying to find a conclusion on that. The research is named Fake It, Attacking Privacy Through Exploiting Digital Assistants Using Deepfakes. And essentially in this research, an experiment was conducted. 12 volunteers were gathered and were instructed to send audio recordings of their voices. Along with this, their age, sex, fluency in English, and their accent/ethnic background was also recorded in the data. And after this, an open source text-to-speech was set up based on the recordings that were sent to them, and deepfakes were made of these volunteers. For those who do not know what deepfakes are essentially just a video, or in this case audio, of a person's face, voice, or body that has been altered or manipulated digitally, so that they can appear to be someone that they are not. So this research was made, and there are shown to be some scary results, as the digital assistants that we use in our everyday lives were being tested for this. So with the deepfakes, or with the AI generated voices that were created, these digital assistants were put to the test to see if they could potentially detect, or see if they would ignore or obey the fake voices. And as we see here, the results show that these digital assistants were showing high rates of eliciting calendar appointments, contact phone numbers, and even personal user addresses from just the fake voice alone. So as we see here, eliciting calendar appointments was 100% from Alexa, 92% from Google, phone numbers was 75% from Alexa, and personal user address was 75% from Google. So if AI digital assistants can be fooled, we can likely see humans be fooled as well, and this can lead to be something very dangerous if it's in the wrong hands. So how can we aim towards detection? And the current answer to that is through deep neural networks. These have been designed to represent a sophisticated approach of both artificial intelligence and machine learning by learning or extracting representations of data through the composition of nonlinear transformations. An easier way to summarize that is this has been deep neural networks are essentially trained on both real and fake or synthesized voices, the data that contains them, and the more and more they're trained, the greater their ability is to discern the differences between both the real and fake. And with this, we can implement a potential AI voice detection program. So what is the scope, or what is the goal for my research? One main thing that led me to focusing on detection is the lack of availability. I don't really see detection being too scaled to the generation that we see today. Obviously, detection of texts is something that has been on the rise lately, especially in for classes, detecting AI generated text for essays or other text. And while that seems to be the case, I can tell that there hasn't been AI voice detection as much as there is generated. And I came to that conclusion the more and more that I proceeded on with this research. And I'm starting to see that detection is really starting to become a necessity in the cases where people are using fake voices for unethical reasons. And a good example of that is for scams. And one example of one example of a scam that was used through AI fake voices was in this article here, the terrifying AI scam that uses your loved one voice, created by Charles Bethia. And just a little bit of a summary on what was contained in this article. So this article begins with the story of a couple sleeping in their Brooklyn home. Fake names were used in this story to protect the privacy of those who reported this. But the woman sleeping in her bed was Robin, while her husband was named Steve. And Steve's mother, Mona, repeatedly kept calling Robin's phone. And once Robin eventually picked up, Mona sounded like she was panicking, repeatedly saying, "I can't do this." And Robin woke her husband up, Steve, and when he picked up the phone, he heard a relaxed male voice telling him he will not call the police and that the man has Mona at gunpoint. So, long story short, the man threatening to, hurt or maybe even kill Mona asked Steve for money to save Mona's life. And once that money was sent, Steve called, the phone was hung up, and Steve called back multiple times. Mona eventually answered in her bed, sounding completely fine, as if nothing ever happened. So somehow, some way, the scammer was able to get Mona's voice and generate a fake voice, pretending as if she was in danger, to scam Steve out of, I believe, $250. I'm sorry, $750, because it was $500 at first, and then the criminal ended up, asking for $250 more. So we see here, and this is just one of many, many cases where AI generation or AI voice generation has been used to scam people. So here are my research questions. For the first one, what are the advantages and discrepancies in current AI detection solutions, and how can they be implemented or improved to create potential approaches for future designs? And the second question is, one issue with voice detection is that AI is known to be more trained with data from well-known individuals such as celebrities. How can a new, more effective solution, or more efficient solution, help contribute to getting voice detection on scale, with the AI being able to consistently train itself with new data? So this was kind of what I was discussing with AI detection being on scale, because it's not always a celebrity we're trying to detect. What if it's a loved one, like the article mentioned prior to this? Well, what are some current solutions? So here's my related work section. One big one that I really love looking over was deep sonar, and this was the implementation of deep neural networks, which was what we discussed earlier about how it trains itself with both real and fake data to be able to discern the differences. So like I said in the first point, this is trained AI with both real and fake data, and this is done by capturing the layer-wise neuron behaviors for both real and fake voices. And I kind of have an image here to kind of create an image to create a bit of an idea for you guys. And here are some results for a little bit of an experiment used with deep sonar. So to set up this experiment, both real and synthesized fake voices were gathered with a good diversity in gender, language, and accents. And all of the real voices were collected online through the internet, while the fake voices were generated through techniques such as voice cloning and text-to-speech. And finally, the deep neural network-based speech recognition system is implemented to distinguish the real from the fake. So this research was trying to answer what is the performance of deep sonar in discerning these two types of voices, as in text-to-speech and voice cloning. And the second question was whether deep sonar is robust against voice manipulation attacks, including voice conversions and additive real-world noises at various magnitudes. And I think one thing that I really want to pinpoint here, you guys can see my mouse, is this EER, which is, I believe, stands for equal error rate. And comparing, at least for this one, with deep sonar, we can see that this equal error rate is really, really low, which is what we like to see here, because it shows that this detection is scary precise, and it shows that there is little to no error, which we'll see here. This provided very promising results with an equal error rate of under 2% across multiple data sets. However, there seems to be some limitations that were mentioned during this research, one being the effect of real-world noises on the performance of deep sonar, which we kind of see an idea of these real-world noises here on this image. So some of these examples are, for indoors, it's just footsteps, or outdoors being these examples: fireworks, train, wind. Here, if you can't trace it, fireworks, train, wind, thunderstorms. This seems to affect the performance of deep sonar if these real-world noises are involved in the data that it's trained with, or in the data that it is trying to detect. A potential solution that we see here is voice denoising, which is essentially extracting pieces, like certain noises in the audio, to make it more clean and efficient. And that is something to possibly consider if providing a framework for a new solution. Another piece of research that I found from outside of my personal experiment is an NPR article, and this article covered a couple of AI detection sites, and we're even able to get in contact with the CEO of each site to provide a review of how well each one is. AI voice detector and AI or not, which both cost subscriptions to use. The CEO of the detector for AI voice detector stated that if the model predicted that the clip was 60% or more likely to be generated, then it will state that it was generated by AI. But apparently there was, I believe, an update that changed it to where 80% or more are deemed highly likely, while 20% or 80% or more are deemed highly likely to be generated, while 20% are highly likely to be real. And NPR was even able, or the writer for NPR was even able to test a few samples that NPR submitted, and out of the 84 samples that NPR submitted, 20 were wrongly identified by the program. And AI or not also stated, the CEO for AI or not also had a statement for this article stating that the detector is based on client-specific use cases. And another thing that was mentioned in this article that I didn't add but I wanted to discuss was something similar to what my second research question was here. So this article helped introduce the idea to me that detection really isn't up to scale, and like, while you might have not as much trouble detecting celebrities' fake voices, which we do see online, so it is beneficial to help prove that these deep fakes aren't real. In the case where a loved one or someone close to you, or even someone who just isn't real, or someone who just isn't well known, is being used for a fake voice, AI hasn't really been trained with that, and for that reason someone in the NPR article stated that AI detection, or AI voice detection, wasn't up to scale with at least a generation. So this led to my personal case study that I wanted to pursue. So before analyzing detection sites, I wanted to create a case study to test the reliability of AI generation sites online available to the public. While there was struggle with finding detection sites, especially detection sites that were free to use for anyone, there wasn't as much trouble with finding a generation site. Along with using the generation site, it was very simple. The instructions were clear, and I wanted to use that. So the Lovell AI generation tool was used for this study, and voice clones were gathered from 6 volunteers, and with those fake voices, their personal digital assistants were tested to see if they would respond to those voices generated by AI. So all 6 volunteers had iPhones, so Siri was used in this case. And Siri was just used to, you know, check if they would respond to the command to call someone. So you would just say, you would use a fake voice, and through text to speech, well, first you would generate the fake voice. So Lovell AI had a very neat way to voice clone. Just gave you a couple scripts that you had to record. So you submit those voice recordings, and in just a few seconds, the clip was I'm so sorry, the fake voice was created, and from then on it's just text to speech. So you would just type, "Hey Siri," so on and so forth, and then Siri actually activated on my phone. I'm sorry, and then so on and so forth. So, "Hey Siri, call blank," and then based off whether it would succeed or whether it would fail, if Siri did respond and obeyed the command, it was deemed successful, and if not, it was deemed a failure. So here are my results. As I said, I gathered 6. I also included gender, race / ethnicity, and along with accents, and then whether it succeeded or failed. Very similar to the Fake It research, where they took fake voices and tried to elicit personal information through those fake voices with an iPad, a Samsung tablet, and Amazon Echo Show 5. While it seemed to do well, yeah, the person 2 did have failure, but everyone else seemed to show success. So 5 out of 6 people showed successful results, providing an 83% success rate, and it ended out to be really well. And all the people that did volunteer had very, very simple instructions. So Lovell AI was very straightforward about using it, which goes to prove that not only is it easy to access, but it's very simple to use AI voice generation, which when I found seemed to be really exciting, but also in the case where it gets into the wrong hands, it could be really dangerous. So for my future plans, to conclude, there are still plans to pursue this research and to begin an increase in the case study I presented just before this. I do wish to increase the sample size. I do believe the sample size was smaller than I intended, but due to the time constraint, I wasn't able to gather as many people as I wished. Along with the sample size, I wish there was more diversity in the control groups, in this case being gender, race, and accents. And furthermore, this is just a case study. I still want the main goal of this research to be pursuing a potential solution or framework for AI voice detection, not generation. So this case study did help get closer to that goal, but I don't want to take away from what I want to pursue ultimately, which is reviewing current solutions. Well, that's what my next step to review current solutions, look at their pluses and flaws, and implement a new idea for future AI detecting. And here are my references, and I believe that is it. For those who made it to the end, thank you for listening, and I hope you have a great rest of your day. Thank you.